So this is a behind-the-scenes tour of cloudfoundry.com, Platform as a Service. I'm Dave McCrory, and this is Martin England. And we're going to walk you through actually a top-down view of what cloudfoundry.com is and then how it actually operates and some of the behind the scenes of the cloudfoundry.com service. So this is a little bit deeper view than what the average person would have into not only what Cloud Foundry is, but how it actually works, and then what we do to make it work. It's a standard disclaimer. Obviously, this presentation should not affect the share price. I guess that's the really short version of what this is all about. So this is kind of what we at VMware talk about as the three layers. You'll hear about this in tons of presentations. You may have already heard about this many, many times. Layers 1, 2, and 3. So the infrastructure, the platform, and the software. So infrastructure being the classic vSphere, vCenter. Platform being all of the vFabric things you hear about, as well as Cloud Foundry. That's all considered in the platform layer. And then the software layer are some of the recent acquisitions we've made. SlideRocket would be an example, or SocialCast. Those would all be examples of SaaS types of services that are involved in what VMware does. So we look at infrastructure as a service as a way of leveraging storage, network, and compute. And what you put into infrastructure as a service being VM images, VDI images, app and OS images, ACE packages, anything like that where you're effectively just shoving something that's an entire OS or lower directly into the platform and leveraging really what you could think of as the raw resources and components. In Layer 2, a traditional style of Layer 2 solution of Platform as a Service, you would upload code and libraries. And effectively, what Platform as a Service would do is take that code and library package and literally start your app. So you would push the code and the libraries up, and effectively you would have an application running. We look at Platform as a Service a little bit differently than that with Cloud Foundry. With Cloud Foundry, we look at the world as app instances and services. So these are some examples. You can see all of these are runtimes and frameworks. These are all supported by either cloudfoundry.com or the open source repo. And the services are services that actually run today in cloudfoundry.com. So you'll see MySQL, MongoDB, that's a document-oriented database if you aren't familiar with that. Redis, that's a key value store. And RabbitMQ is a messaging solution, so literally the ability to pass messages between application instances. So the view of the world of how we approach applications is around runtimes and frameworks, and you can see the idea being that all of these different types of cloud solutions can leverage this cloud application platform. And if you'll see down towards the bottom, we have data persistence under the common platform services along with messaging, load balancing, and other services. We'll talk a lot more about that in just a minute and how all this really ties together. So what is cloudfoundry.com? It's the Cloud Foundry solution, which is what we actually have in the open source repo today. That includes support for the runtimes and frameworks that you see, along with services. And all of that is running on top of vCenter, vSphere. So we literally have racks of equipment with vSphere, vCenter, with Cloud Foundry running on top of it, and that is the service that we're providing today. It is a classic enterprise stack, which is slightly different than what a traditional cloud stack that you would see, say, run by Amazon or someone like that. They're using incredibly commoditized, inexpensive hardware at massive scale, not enterprise-class hardware. And that's by their design, but the reality is that if you wanted to run something like Cloud Foundry behind your firewall, you would most likely be running it on enterprise-grade hardware today, not a bunch of commodity boxes that are just no SAN, no redundancy of that type. You would probably not be running it on the absolute cheapest possible equipment you could find. So those are some of the differences, and that's some of what makes CloudFoundry.com a little bit different than your average public PaaS service. So there's also CloudFoundry.org, and the difference is the .org is in support of the open source software that Cloud Foundry is comprised of. We open sourced Cloud Foundry in April, and you can download the code yourself from GitHub. It's github.com/CloudFoundry. It's Apache 2 licensed, so you're basically unencumbered as far as what you do with the code and the software. If you wanted to, you could set up your own environment based on that open source code and deploy it behind your firewall. We have several other ways that we leverage that code, including something we call microcloud, which is the entire Cloud Foundry stack inside of a single VM you can download. And then in addition to that, that's the same code that's actually running CloudFoundry.com. So traditionally, when you deploy an app, classic three-tier app, you have web, app, and DB. You might put those in separate VMs. You might put them all inside of the same VM. This would be a typical deployment. What you'll find is it's still a difficult process, even with virtualization. Not from the provisioning the VMs, but from the process of allocating those resources for the custom software app that you have, then doing the installation and the configuration of the app, not the VM or the image. When there are upgrades or changes to that enterprise app that the dev team has built, etc., it's usually a very entailed upgrade process. There's a lot of testing that at least should occur, unless you want to incur that risk. And even updates are painful. Even updates of the OS are painful in a lot of cases. At least if you have to reboot, it's painful. So the ability to move the virtual machine around and have the application inside the virtual machine stay up is obviously valuable. But if the app were able to tolerate a little bit more, life would be easier as well. So with Cloud Foundry, you actually push your app into the Cloud Foundry instance. So this is literally taking an app that you wrote, pushing the code with this command, and actually that VMC push my app really is the command line that you would type to push this app up. And if you wanted to then scale the app, you literally see the VMC instances, my app 5, that would actually scale this app out into 5 instances. So upgrades, slightly more entailed process, but literally you can map a URL to an application and live change that mapping. And how all this works, don't worry, I'm going to explain in a minute, so it won't just be this hocus-pocus smoke and mirrors. Doing updates, you can also literally change the code, and when you do a VMC update, it will take the new code, it will push it up into the system and literally stop and start all automatically for you. So this provides a lot of value and lowers the risk. And the other great thing about using something like this is that you can push this in the same fashion to many instances of Cloud Foundry, and you don't have to change the code, you don't have to change the commands. The only difference is targeting a different cloud, and that's a single command to target a different cloud than the one that you're currently using and talking to. So this is a logical view of Cloud Foundry. And so this is kind of where we get into the whys and hows of what we can do and why Cloud Foundry can and does work the way it does. So the DEAs over there are, we classically call them droplet execution agents. I call them dynamic execution agents. What they really are VMs with an agent on them. The ones we use are leveraging Ubuntu, and they contain all of the necessary OS and other parts for you to be able to start your application up. So if it's the JVM or whatever it happens to be, all of that is contained inside of that DEA. Now, how the DEA gets the application and leverages it is by that VMC client that I was talking to actually communicating to the cloud controllers. And then the cloud controller ultimately making a deployment request, which will deploy that app over to the DEA. It will wire up any services like the database that we have in the example here. Once the app says, I've started on the DEA then communicates that, and ultimately the load balancers and routers adjust. Now, something important to realize, when we're talking about load balancers and routers, these aren't Cisco load balancer or router combos or an F5 or something. These are in software. So these are software load balancers and routers that we can dynamically adjust and change on the fly. And this is built into the Cloud Foundry open source as well. So everything on here is all contained inside. You also see this message bus. This is NATS. This is how all of these components are able to talk to each other, is through the message bus. And the health manager is what keeps things honest. And by that, I mean the health manager actually views everything that's being communicated across this message bus and makes sure that the cloud controller actually is in tune with what the reality is versus what it's asked for. So maybe the cloud controller asks for 5 of these DEAs to start an application, and they don't all start. The health manager is what figures that out and then trues up the cloud controller and keeps everything honest. So this is actually a distributed system. It may seem a little bit complex, but it's really not. And the power it gives you and what it enables you to do is why we're able to do lots of interesting things with application deployments and make it really, really easy and painless, including doing things like upgrading the cloudfoundry.com website, which runs on Cloud Foundry, by the way, upgrading it on the fly without any downtime, without users dropping sessions, without any of that happening. It happens seamlessly. No one even knows that we've made the upgrade. It just happens. That's part of the design of the system. The one thing that it does assume is if you want no downtime at all, that you do have to have more than one application instance running. So you can't have a single instance and on the fly upgrade that single instance without any other instance existing at all. That's kind of one of the limitations of Cloud Foundry, although I'm not aware of a system that would let you upgrade on the fly without any downtime, without another instance either. So going a little bit further, it's also important to realize that in the normal operations of Cloud Foundry, all of these components are scaled out. We have hundreds to thousands of DEAs on the .com over here, lots of services, cloud controllers. Everything is designed to scale out. And when things come online and they attach to the message bus, they announce themselves. So things can come and go in the system, and the system will recognize that and automatically adjust itself. So those are things that are inherent into the design of Cloud Foundry itself. I'm going to go ahead and actually turn it over to Martin, who will start talking about the actual operations and how we do things inside of Cloud Foundry.
Thanks. So when we work on Cloud Foundry, we try to be as agile as possible, which means pushing code several times a week. And to be able to do that, we can't request downtime for 5 hours to revamp the whole site. So we have a fully automated process to do all of that by shifting out pieces gradually without the end user or the applications noticing. And you can use the same process yourself if you set up your behind the firewall Cloud Foundry. And every upgrade we do starts with a canary. And so we do a deployment if we want to replace all the DEAs with a new Linux version or a patched Linux version. We do first a deployment of a canary instance and make sure that it comes up okay, so we can see a response from the system. And if that deployment fails, then we abort and say, hey, it's not working. So then we won't continue rolling out the changes. We're going to show an example how we switch out all the DEAs. So the first thing we do is we disconnect the execution agent from the message bus, which means it will no longer try to start new applications on that instance. Then we drain all the current HTTP sessions from the execution agent, so we know there's no longer traffic going there. And finally, we drain the applications, because if you have an application which is running on that instance, once we shut off that VM, you'll now have one less. So the cloud controller will then start up. If you have said, I want 5 instances, and after shutting down the VM, we'll now have 4. And then we tell the cloud controller, hey, go make sure we actually have 5. And then we're ready to patch, upgrade, fix, do whatever we want on that VM. And once we're done, we just reconnect to the message bus, which means that the execution agent will start responding to application requests again. And we have this fully automated, so when we do this, we can do this for thousands of execution agents within a couple of minutes. And I'm going to talk a little about an outage we had, which occurred to a power failure to a storage unit. And the interesting thing is not sort of why the outage happened, but the effects it had. So it made the cloud controller database, which is where we store all the persistent states about how many application instances should be running and so on. So that database went away. So we actually no longer knew how many applications instances should be running. You couldn't, as an end user, create new applications, or you couldn't start or stop them. Or you couldn't say, I want 5 more instances. So that database went away, but the whole system kept on working. So existing applications kept on running. And that's due to the fact that it's a distributed system, so you can actually take the loss of a component and still have a partially working system. Since every piece here communicates over the message bus, there's no shared state. Shared state in the system. So when requests come in for a website, it goes to the load balancers, then to the routers, and then to the execution agent, to the target application. And all that state is shared over the message bus. So while we've worked on bringing back the database, the end users could still access their applications. And we built Cloud Foundry with self-healing features, such that if you have an execution agent go away, you have a Linux kernel panic, and then you have a number of application instances go away, the health manager is monitoring sort of all the applications running and correlating that with what's in the cloud controller database, which is sort of what the state of the world should be, and then he looks at what the actual state is. And once he sees that, oh, I no longer have 5 instances of this application, which should have 5, then he'll go poke the cloud controller and say, hey, you need to fix this. So the cloud controller then says, oh, hey, yeah, I should have 5, there are 4, I'll start up a new one. And this is very quick. So usually when we do testing, we shoot the processes in the head, just kill -9, and they instantly respawn on another execution agent. And if you have a kernel panic and that execution agent VM locks up, once you go and fix it and reset it, it'll connect back to the message bus announcing itself, saying, hey, I'm here now, and it'll then immediately start to respond to new requests to run new applications. So yeah, here's a picture showing that if this DEA goes away, and you spawn up another one, it automatically connects to the message bus, announcing itself, saying, hey, I'm a new execution agent. And once the cloud controller says, hey, I need someone to run a new application for me, he'll respond and say, hey, yeah, I can do that.
Sure. So the the concept of canary is kind of a must if you've been following along with what we're talking about. And the idea is that that's your test case before you actually flip the switch and begin generating and moving your entire app from one iteration to another. That's kind of the test case. If the canary actually succeeds, then things will automatically roll forward, and if it does not, if it dies for whatever reason, then things are rolled back, and you have to try again later, hopefully figuring out what's wrong. Load balancers, routers, cloud controllers have to be scaled as DEA scale, so the throughput of any given router and load balancer is still limited to some degree, and so you have to scale them out. Usually I think it's a 6-to-1 ratio, something like that. So 6 DEAs against each load balancer and router. But at some point, depending on the traffic that those DEAs are receiving, the numbers might vary. The system was designed to be maintained with zero downtime, which is what we were just talking about. It has broad applicability. It does assume that both operations understands roughly what's happening along with the developers. So we talked a lot about externalizing the state outside of the application itself. Now, externalizing might be shoving it into the database using the services, or it might also be externalizing the state by pushing it across the message bus, or just not actually trying to store different things inside the application itself. Finally, Scalability is limited to the number of messages we can get through the message bus, and what that means is that the actual scalability of a single Cloud Foundry instance in and of itself is limited to the throughput of that message bus overall. Currently, that's about 1 million messages per second. That's a lot of messages. That would be an incredibly large system, but who knows? Facebook or Twitter or something like that would absolutely exceed 1 million messages per second. But most enterprises and enterprise applications won't come near this. And in a lot of cases, you would end up deploying several clouds anyway, just because of silos in either business units or other needs to separate and have truly distinct clouds. And with that, we'll take questions. And also a brief note, I was told the Wi-Fi network is down. So I have no idea why or anything else, but I was told to tell you guys that. So if anyone has questions, I know we have the mics up front, or you can talk really loudly. Either one should work. Is it? I can hear you. I can repeat the question. Oh, there we go.
Is the health manager able to communicate directly to the cloud controller, bypassing the message bus?
No, the cloud controller talks through the health manager will talk through the message bus. However, we're in the process of making it so that the message bus is clustered and redundant. And so you would have 2 exit points to be able to communicate across a clustered message bus. So right now, at this very instant, if you download the open source, the message bus, in theory, could be a single point of failure, but that's why we haven't GA'd yet, is because of spoffs like that. But I kind of, is that where you were going with this?
Yeah.
Yeah. So that'll be resolved before we actually GA the Cloud Foundry code and everything else around that.
Thank you.
You're welcome.
So, 2 questions based on, when is GA? When do you guys have that?
We're estimating GA will be the first half of next year right now.
Okay.
When exactly, I can't say.
Second question is, the code for the upgrading of a running Cloud Foundry instance where you're rolling out upgrades to the DEAs and things that you described, is that part of the open source? Do you guys have that available?
You can manually roll out those DEAs right now, and we're working on providing some ways of doing that via scripts. I don't know if it's all available right now, but you could still achieve roughly the same thing.
Yeah, I'm talking about the automation stuff that you guys are talking about.
So the automation of, say, an application and doing that piece is there right now.
The actual Cloud Foundry.
The instance itself?
Yeah, like if you want us to push a new version of Cloud Foundry out, and not have downtime and not do it manually, have it automated, like what you do to support cloudfoundry.com.
So I think some of that is, but not all of it yet. I would say over the next, say, couple of months, you'll see the rest of it available where you could do it yourself. Will it all be finished and polished exactly the way we use it? I don't know about that, but you would be able to do the same thing, and I'm pretty sure that you'll have the ability to do that. I just don't know how much of that's going to be available directly that we use internally. Unsure of that right now.
Okay, thanks.
Okay, thank you.
Hey, good session so far, by the way. A quick question on frameworks. I saw Spring and Rails. Any plans for other future frameworks to be supported, specifically OSGI?
So I believe you'll be able to do OSGI. We also announced, in fact, it was last week that we're going to that we support PHP and Python as well, and we're at least trying to figure out the best way to support .NET apps as well. So I would expect in a reasonable time frame, any of the major frameworks and runtimes out there will end up being supported in Cloud Foundry. It's more of how quickly we can get to the things. Some of them automatically work, like JRuby was, I think, only a couple of lines of code change in Erlang that we accepted early on as a pull request. That was an external person that actually did the work for Erlang. that was within a few days of launch that we were able to turn that on. So yeah, it's not a limiting factor. The platform itself was designed specifically with the intent of being able to support all the different languages, runtimes, frameworks that are out there.
So are you guys publishing a roadmap for that, or does it just depend on your release cycle and priorities?
Well, really, we're trying to have a commercial version of Cloud Foundry out first before we have a published roadmap, so to speak, of the next thing.
Okay, thanks.
You're welcome. Yes.
So inside of Cloud Foundry itself, how do you scale out the nodes that you've got running? Do you have some nodes that are just DEAs, some nodes that are just RabbitMQ service instances, some that are just RDBMS, or is it kind of a homogeneous mix?
So they're separated. We have pools of DEAs. The DEAs are actually, the DEAs are all the same in our case. Mm-hmm. So all DEAs are capable of running all applications. You could actually do that differently. You could have some DEAs that are specifically dedicated to just Java, or that run on a specific class of hardware, and then other sets of DEAs that only run Ruby and are a different class, and they all communicate, and only the DEAs capable of supporting that specific application would respond to the request to bring that app online. The services operate in a similar way. So you would have nodes that would purely be Mongo nodes or MySQL nodes. So they would be dedicated to that task. There wouldn't be an intermixing of them.
Gotcha. Okay.
Okay.
What's the impetus behind using enterprise-class hardware? If the applications don't really, the resiliency is already designed into the app, what's the necessity for not deploying ESXi boxes all over the place with local storage, and using Cloud Foundry as the platform on top of that?
You could do that, but most enterprise IT operations groups wouldn't be accustomed to having a totally different class of hardware with local storage. So that would be very disruptive to their operational processes. At the same time, Cloud Foundry is capable of running a traditional 3-tier app. And so that ability to have that portion flexible is kind of what has caused us to do .com in that specific way. We're looking at if there are other options to maybe provide different classes of services. And the different classes of services would be determined based on what the underlying hardware is and how you write your app. Really, it's the idea of it's more expensive to run your app on the specialized, what I call enterprise class hardware, but you risk less problems with a single instance running into a problem due to hardware failure. So the idea is to give the flexibility. You can run it on the commodity with local storage. That is totally doable. But in order to stair-step people onto something like this, which is new and complex and difficult to understand, at least at first, it's easier to just say, look, you can follow the same process as you did before. You can spin up your VMs on the same type of environment. You can keep all of that operations the same. You're welcome.
Question on the framework around data centers. Can you span the service across data centers, especially on a global scale? So when you back up DEAs, can you move them between data centers, say from the U.S. to China to Europe?
What you would try and do is probably deploy the code in all of those different places. Instead, it would be faster to deploy the code, or you would have separate Cloud Foundry instances. So you wouldn't really want to move the virtual machine itself around. You'd probably try and replicate the services or the services data. You potentially could move them around, but it would get very messy and complicated. The idea would be to ultimately just move the app instances around. Because they're stateless, it won't matter. And ultimately, we'll probably have some type of geographic awareness, but there's no, say, geo-awareness or something else in Cloud Foundry today.
Okay, thanks.
Okay.
So you mentioned GA. I'm going to ask another question.
Sure.
So Cloud Foundry, as it is right now, is really cool, very powerful. What are you hoping to add in order to get to GA? What do you guys still feel needs to be added in order to get to your GA release?
So several things, including I was mentioning the NATs being clustered. There's some changes we're looking at on trying to improve the cloud controller, and then there's some other automation components that we're looking at, and just trying to add the additional languages that I mentioned. All of those things are things we're trying to figure out, and then once we're comfortable with that, then trying to have it kind of go through its paces for a while before we actually GA it, because we have to be comfortable with supporting it. That's one of the big things you'll get with GA is real support. Right now it's community support. If you deploy Cloud Foundry behind the firewall or somewhere else, it's more of a best effort thing. And granted, our engineering team does monitor the support site and all of the different groups and forums and things, and we respond pretty fast to all sorts of questions and things, but that's all free and best effort, so it's not as high a priority as it would be if you were, paying for that support.
Real product or whatever, right?
Right, that's right.
So the support, as far as Cloud Foundry, you say you're going to make some Cloud Controller, you're going to make some changes. What do you see rolling into Cloud Controller?
I think it's just trying to make it more resilient, more scalable, have some more flexibility. I can't really go into deeper specifics than that right now.
Okay, thanks.
Okay, thank you.
Are you looking at expanding Cloud Foundry to something like Go from ThoughtWorks that takes it all the way from a software development build all the way through deployment?
We've thought about things like that. Right now, we're really focused on just bringing those app instances online and having the flexibility and capability that we can with being able to have as many app instances and services as we can. We haven't really looked at anything past that yet. We're still early on as far as we want to get a 1.0 product that we're happy and proud of, but is fairly limited in scope initially, and then improve after that.
Do you know if there's something in the community that's built up that front end of that process?
I missed the last part of what you said.
Do you know if there's anything in the community that has built up that front end process?
Not that I'm aware of. We have definitely thought about that and are definitely talking about that internally. So I would expect that in a reasonable time you'll at least see one or more things like that, but they won't be baked into Cloud Foundry itself as far as just part of what we provide.
Okay. Thank you.
Can you talk a little bit about the health monitor? If that crashes and comes back up again, how long does it take to discover what is really out there, what's running, in order to reconcile it with what should be, as well as it's a little bit of insight. Is it just listening on the bus to determine that, or is it actively going out and probing the environment?
So it will interrogate the components when it comes online. It does also passively listen to all the messages that pass back and forth. It's usually, I believe the default's a 5-minute interval that it sits there and waits and listens to the world, and then it trues up the cloud controller after that.
Okay, so roughly 5 minutes to actually have a representation of what is actually out there?
No, it'll get it faster than that. It'll be seconds where it has the actual representation of what's out there. But on a normal basis, if it were just operating and it had not crashed, as you had said, then at 5-minute intervals, it will true up the cloud controller. That's actually adjustable, by the way. You can make it true it up more frequently or less frequently, whatever kind of your taste is.
Okay, thanks.
You're welcome.
Hi, good morning.
Good morning.
I have 3 little questions. From a client perspective, if I decide to host, if I decide to host an application on your service, how can I be sure that I will get enough performance to run my application? And what's the rationale to decide if I need more VMs or not from your side?
So we primarily look at requests per second that your app is dealing with, and that would be what you would decide, because effectively it's traffic in and traffic through each of the layers. That's all it is. That's really what your application is a lot of traffic. It's either traffic to the database, traffic between a web and an app tier, or traffic between, say, a web tier and a router and load balancer. And so that's really how we determine what happens, is by the traffic. We don't currently, while CloudFoundry.com's in beta, offer an SLA. When we actually turn on the commercial CloudFoundry.com, we're at least looking at what are the different levels of services that we provide and how we will charge for that. We haven't figured that out yet, by the way, so we're certainly interested in people's thoughts around it, but we don't have a kind of a hard and fast rule even now that we've figured out for what we're going to do with that just yet.
Okay. So we'll skip the cost question.
Well, you could also keep it small, keep it down to, say, 2 instances, and see if you seem to see latency or if the response time is slow. And with a single command, you can increase the instances. Something that's important that I don't think we touched on is spinning up new instances takes seconds. And by seconds, I mean when we launched Cloud Foundry, at the launch, we deployed an app and spun up 200 instances in less than 15 seconds. So spinning up app instances is very, very fast, very inexpensive, and then shrinking back down is very easy and again, just as fast.
Really elastic.
That's right, very elastic.
And the last one is in regards about capacity. What plans or what processes do you have on your side to ensure that you have enough capacity to support the demand?
So today we effectively have a Slack pool of DEAs, and the way DEAs work, because you can dynamically add and remove them, it's not all that difficult even to just manually add a set of DEAs if you needed to. We have a distribution algorithm that's applied to the way applications are deployed, and it evenly distributes the load across all of the DEAs. So as long as you have a pool of DEAs that are all capable of hosting that specific app, the load is distributed very, very evenly across them. So even monitoring a single DEA, if they're all the same, you would have a pretty good idea of what the load looks like across all of them because of the way the apps are distributed.
Okay, thank you so much.
Thank you.
Hi. Have you had any rogue applications running on any of the DEA nodes, tying up resources, threads, something like that?
We limit the applications by wrapping the processes that the applications run in. So each app instance is tied to a process. So we look at that, and we're able to throttle them based around process restrictions. You do have problems where applications will seemingly come up and go back down, and then come back up and go back down. We call that flapping. When the flapping happens, we actually will go and kill that app and then mark it as having problems automatically. That's something that the health manager and cloud controller will coordinate on. And so we can even see that by their ability to respond over on the side by the routers. And so if that happens, and I think it's if we see that happen 3 times within I can't remember the time frame off the top of my head, but it's a very short time frame. If that happens, we'll just take the app out based on that. And obviously the app has some type of logic problem in it, so you wouldn't want to run that app anyway in that case.
Okay. And coming back to the distribution algorithm, is there any way to, let's say I have 2 applications, one is very high important, the other is probably an internal application. Is there any way to, with the same cloud controller, but a different set of DEA nodes, so that only I don't know how to implement it, either they respond to receiving this application and the other DEAs will not respond. I want basically an application isolation.
So there are different ways to isolate the applications. One is by turning on, the way we run DEAs, there are 2 ways you can set up DEAs. You can set them up as single tenant or multi-tenant. So single-tenant DEAs mean that a single account gets a DEA, and it is the only one that can use that DEA for any purpose. Multi-tenant, instead of it basically expecting the VM to be the encapsulation, it expects the process to be the encapsulation. And so the whole intent of that capability is to deal with kind of the Coke-Pepsi problem. Coke and Pepsi would never want to be on that same VM and wouldn't want to just be a process away from each other. So you could turn on single tenancy mode and you're guaranteed that they would be in different VMs with that isolation. But if you operate, say, a public cloud, like we do with cloudfoundry.com, you couldn't afford to have every single deployed app in a separate VM. So you would want to move to process isolation, and so that's why we would have multi-tenant mode. In addition to that, you can also take the DEAs and you can specify the runtimes that they're capable of supporting. So you can slice and dice them many ways, and if you set it up in that fashion, it will only allow that specific class of app to be deployed to it. So you could very much set something up that would do what you're talking about.
But you cannot make a DEA app specific, though, right?
You might have to
some other metadata.
You might have to change the code. If you wanted to make a DEA app specific, I'd just say create an account that's specific for that app and tie it, and that's what I would do.
Okay.
Just make the account in the app the same.
Okay. Thank you.
You're welcome.
Can the controller respond to infrastructure messages coming on the message bus, or is it customizable to other events?
So the cloud controller today only, he's kind of what Derek Collison, the CTO of Cloud Foundry, likes to say. He's the king. The cloud controller just issues commands and says things need to happen, and it doesn't listen around to see what else is happening or what's occurring or anything else. That's the health manager's job. So you could certainly modify the cloud controller to do something like that.
So in that case, the health manager, can it listen to events, and is it customizable?
The health manager?
Yes.
It is. The components themselves, by the way, communicate across NATs using JSON messages. And if you've ever seen what a JSON message looks like, it's very readable. It's not that difficult to actually look at. And it's pretty easy to hook into even the NAT's message bus itself if you wanted to. It just kind of depends on your taste for how far off the ranch you want to go with your customization versus what's currently there.
One more question, that you mentioned that load balancer and router, they're all in software.
That's right.
Could you explain why it is not using standard routers and load balancer?
Well, if you think about how many apps you could spin up and how many instances, every instance you spin up requires an IP with a port address that has to be registered against a router, and then you have host header information that's trying to pass through the load balancer, and you have to end up being able to figure out which DEAs on which ports are supporting this app instance, and you're trying to ultimately route all of these web requests in a load balanced way through the system to those DEAs evenly. And trying to do that with physical load balancers, when you're having DEAs come on and offline and you're scaling out how you do these routes and you're updating things that rapidly, it's just not possible. And it would be incredibly complex, and then we'd be tied to specific hardware too, because trying to support every single network vendor out there with their stuff to be able to update all of the information would just be an impossible task. So we actually do have load balancers above the load balancers that are in software, but ultimately the load balancers in software give us the flexibility. So we're able to update all of that in, seconds at the most, usually sub-seconds, it's milliseconds that we're able to add and remove those entries.
And the final question is that how does it interface with vCloud Director solution? Does it or does it not?
So the project as it is independent of what it's actually operating on today. So it doesn't care. There is no interface directly with what's beneath it at all. So it's totally independent.
So you could deploy this solution in a cloud environment?
You could deploy this in any environment you can think of. At least the open source solution you can deploy. Again, we deploy it in a single VM. We have partners that deploy it on all sorts of things. I mean, infrastructure as a service, you can deploy it with the Dell Crowbar stuff. You could deploy it on a physical machine. Okay. You could deploy it across physical machines. It just all depends on what you're looking to do. But it's definitely not tied to any of those things.
Thank you.
Hi. You upgrade the DEA by draining it, patch fixing it, and then reconnecting. Did you consider the pros and cons of putting the next version of a DEA in a virtual machine and just
booting that instead? Is there?
Well, so the secret in the draining, you're basically draining the sessions out so that you have the live old sessions as they end break off, and once the last one is broken off, you take that DEA down. In the meantime, you could have one or more new DEAs that are accepting all new requests, and that's how you can seamlessly move and have the app never actually incur downtime, is because of that process. You could, if you literally bring the VMs up and down, you're still going to cut a session somewhere, and when you do, that's when you'll have that perceived downtime or message.
So you wouldn't bring new DEAs up in new VMs and just wait for the old ones to finish their work and then shut that VM down?
Well, no, I mean, basically that's what we're doing in kind of an automated fashion. We have all new requests come up in these new ones that have come online, and so anything new, any new sessions are established to this side, and as the old sessions break away, these fall down until they're all gone. And so that's how you can just continuously bring online new apps while the old apps are dying, or DEAs in the same fashion. You're just draining it out, bringing it offline.
I misunderstood your slide then, because your slide had you drained the sessions, you did your patching, and then you reconnected, it seemed like, from that same session back to the bus. So you came back online in the same instance, not...
No, you've kind of... So this DEA is upgraded, but when this DEA goes down, the other DEAs can take that application over, and then this DEA comes back online, reconnects, and then it can start taking on applications again. And as long as you do that in a rotating fashion and you don't take all the DEAs down at the same time, you can continue to update them.
You don't terminate the Ubuntu virtual machine completely down, load a fresh instance, and boot it up again for the new DEA. You shut the DEA process down, do your magic to it, and then just fire that process up again?
No, we would shut the whole... Realize that we would shut that whole DEA down, but when we shut that entire DEA down, the idea is that the other DEAs have assumed the load,
sure.
And so then this one gets upgraded and brought online, and then another one gets taken down, upgraded, and then brought in line. And so eventually, as you do that, eventually all of your DEAs will have been upgraded, but you didn't take any of the applications down in the process because they've just been relocated.
I get that. I'll
okay.
catch you.
We can catch up after. That's fine.
So the message bus can handle 1 million messages, right?
Per second, yeah.
When a web request comes in, approximately how many messages does that translate to?
None. Because it's messaging directly to the DEA through the router and load balancer, but that doesn't generate a message on the message bus.
Okay. So it's just handling all the internal...
It's the back end. The message bus is for the back end coordination, not for like web traffic and stuff.
So does the web traffic get routed through the routers and load balancer?
It does get routed through the routers and load balancers, but that wouldn't generate... I mean, maybe it would generate a message or something for a whole session over, X amount of time, but it wouldn't generate... So we're not, say, limited in that fashion.
Got it. Thank you.
Okay, thank you.
Hey, good stuff, guys. Thanks for your session.
Yeah, thank you.
CloudFoundry.com, the DEAs, can they only be started in multi-tenant mode, or can a new account request single tenant?
On CloudFoundry.com, it's all multi-tenant only today. Certainly interested in input on when we kind of go out of beta to GA on CloudFoundry.com, hearing about if it makes sense to offer something like that.
Okay, in that mode, then, can you speak to like the physical isolation of storage, so Coke and Pepsi don't,
So today on CloudFoundry.com, Coke and Pepsi could very easily end up on the same DEA, and they could ultimately be on the same physical storage, but they would be isolated through a whole bunch of other layers with account security and ACLs and a lot of other things. But right now, there isn't kind of that hard separation. The only way you could truly guarantee hard separation would be either based on account or physically stand up another cloud or something like that, and then say you target this specific cloud, which is possible as well. And we're definitely, like I said, we're definitely interested in hearing about thoughts and ideas or motivations of why we would want to look at something like that or not.
Okay, and then the platform infrastructure you're running. Are you running the vFabric stuff like TC Server and?
So we are turning on the vFabric stuff inside of cloudfoundry.com, and we will have the vFabric stuff when we GA. All of the vFabric stuff should be offered in both .com and in the supported product, which is part of the idea. If we're expected to support all of it, if you put in a bad JVM inside of or a bad Tomcat version specifically inside of DEAs, and that's what your problem is, we're not going to be able to help you all that much. If we're supporting that Tomcat instance and you have a problem with that, then you can come wring our neck and say, you need to fix this immediately, and we would fix it.
Right, okay. And then lastly, you mentioned SLAs. You're still working on those. Do you think you'll even try to publish a performance-related SLA?
I don't know. Yeah. I don't know. I wouldn't say it's out of the question, but I don't know. I would say the higher the level of SLA, it's just going to end up costing more one way or another. I mean, ultimately, no matter how efficient we make this system, you're still tied to the costs of redundancy and the performance we can provide. And even that, there's still limits to hardware. I don't care what cloud service or anything else you have. Ultimately, you'll hit some type of cost versus benefit bottleneck.
I was mostly interested in kind of your approach to the best practice of dealing with things that are out of your control, like WAN latency and so on, and how you were going to articulate a performance SLA if you were even going to try.
So I think ultimately it's possible that we'll offer something like that. I don't know for sure. It's certainly not my decision to make, but at the same time, one thing that I think will change is that people are going to learn that they need to try and write more efficient applications, because the benefits will grow more and more and more. The application will be one of the determining factors of just how resilient the uptime is. It won't be purely an expectation of the hardware, and how many requests that application can accept will be based around that as well. And I'm being called for time.
Thanks.